Good morning everyone, and I am Engine Cadet Belia Juan Paulo. So my topic for today is steam turbine components. These are the objectives. At the end of the discussion, the student will be able to: number 1, identify and describe the main components of a steam turbine and their function. Number 2, explain the material used in manufacturing its component and the reason for their selection. So number 3, understand the construction and assembly process of a steam turbine system. Number 4, so recognize the different safety devices used in steam turbines and their importance in safe operation. Number 5, describe the automatic control and operation mechanism that help regulate turbine performance and efficiency. So number 6, appreciate the role of control system in maintaining stability, safety, and energy efficiency and power generation. So what is a steam turbine? So a steam turbine is a device that converts the energy of high pressure, high temperature into mechanical energy by directing the steam onto blades attached to a rotating shaft, which can be used to generate electricity or power machines. So a steam turbine is a machine that changes hot steam into movement. So the steam pushes the blades, making the rotor spin. So this spinning power can be used to make electricity or move other machines. They are the components and its function and manufacturing materials of steam turbine. Number 1, we have casing. The outer shell of the turbine that holds and protects all the internal parts. It is made strong enough to handle high pressure steam and prevent it from escaping. Material we use: cast steel or carbon steel, or sometimes cast iron. So reason for selection: the casing must be able to withstand internal steam pressure and high temperature without deforming. So steel is preferred because it provides high strength or durability and resistance to cracking. So cast iron is used for low pressure turbine due to its lower cost and good machinability. So manufacturing process: the casing is cast in two halves, upper and lower, using sand casting or precision casting, then machined and bolted together. So internal surface are treated with anti-corrosion coatings. So the casing is the outside cover of the turbine. It keeps all the parts inside the safe and stops the steam from escaping. So it is made from strong metal that can handle heat and pressure. So number 2, rotor. The main rotating shaft of the turbine that turns with steam passes through the blades. It curves the blades and transfers the turning motion to other equipment. So material use: forged alloy steel, often chromium molybdenum steel. So reason for selection: the rotor must withstand high rotational speeds, vibration, and heavy stress from steam impact. Forged alloy steel is chosen for its high tensile strength or fatigue resistance and ability to maintain balance at high temperatures. So manufacturing process: the rotor is usually forged as a single solid piece to avoid weak points and ensure stability during long operational hours. So the rotor is the parts that spins inside the turbine. It curves the blades and sends power to other machines. So it is made from strong steel, so it won't break or shake too much when turning fast. So number 3, blades. Curved metal pieces attached to the rotor. When high pressure steam hits them, it causes the rotor spin, converting steam energy into mechanical energy. So material we use: stainless steel or nickel-based alloys or titanium alloys. Reason for selection: blades face high velocity steam, heat, and corrosion. So these materials offer for excellent heat resistance, corrosion protection, and mechanical strength. So manufacturing process. Blades are precision cast or machined in heat treated and surface hardened. So they are attached to the rotor using dovetail or fair-tree joints and tested for balance. So blades are metal pieces that catch the steam and make the rotors spin. So they must be strong because of the hot and fast steam. So they are made from metals that can resist heat and rust. So number 4, nozzles. They guide and control the flow of the steam towards the blades. They increase the speed of the steam to make it hit the blades with enough force for efficient rotation. Material we use: stainless steel or heat-resistant alloy steel. So reason for selection: nozzle directs steam at the correct angle toward the blades. So they must resist corrosion, erosion, and deformation under high pressure and temperature. So manufacturing process: made by precision casting or machining, then polished and aligned to ensure smooth steam flow. Some are integrated with diaphragms during assembly. So the nozzles is guide to the steam towards the blades. So they help the steam hit the blades at the right angle to make good power. So they are made from metals and don't easily change shape from heat. Number 5, bearing. Parts that support the rotor and help it rotate smoothly with little friction, keeping the turbine stable during operation. Material use: babbitt metal, tin copper, antimony alloy, or bronze. Reason for selection: bearings support the rotor and reduce friction. Babbitt metal provides a smooth, low-friction surface with good load-bearing ability. Manufacturing process: bearings are cast or lined with babbitt alloy, then machined and polished to achieve a precise fit. Lubrication system are added to minimize wear. So the bearings help to the rotor spin smoothly with little friction. So they keep the turbine steady and prevent damage. So they are made from smooth metals like bronze or babbitt. So number 6, shaft. A long metal rod connected to the rotor that carries the rotational motion to the other machines such as electric generator. So material use: so nickel chromium alloy steel or carbon steel. So reason for selection: the shaft transmit to torque from the rotor to the generator and must resist bending, twisting, and fatigue. Alloy steel maintains strength and dimensional stability under stress. Manufacturing process: proceed by forging and precision machining, then heat treated to improve hardness and durability. The surface is finally finished to reduce friction. So the shaft connects the turbine to the generator or other machines. So it carries the spinning motion from the rotor. It is made from strong steel, so it won't bend or twist. Number 7, seals. Fitted around the rotor to stop steam from leaking out of the casing, maintaining pressure and efficiency inside the turbine. So material use: nickel chromium alloy steel or carbon steel. Reason for selection: seals prevent steam leakage and maintain pressure. Carbon is ideal due to its heat tolerance and low friction properties, while steel adds durability. Manufacturing process: manufactured by holding or machining the sealing rings, then fitted around the shaft with flexible design to handle expansion and movement. So the seals The seals stop the steam from leaking out of the turbine. So they help keep pressure inside and make the turbine work well. So they are made from materials that can handle heat and movement. Number 8, control system. A device that automatically adjusts and controls the speed of the turbine, ensuring safe, stable, and efficient operation. Material use: stainless steel, brass, and aluminum and electronic materials, sensor and actuators. Reason for selection: the control system regulates steam flow, pressure, and speed. So materials must resist corrosion, heat, and vibration for long-term reliability. Manufacturing process: manufactured by assembling mechanical parts and electronic components. Bulbs and actuators are CNC machine and sensors are calibrated for accuracy. So control system: the control system helps the turbine work safely and properly. It adjusts the speed, pressure, and steam flow automatically. It uses sensor to check if the turbine is running normally. So these are the steps of construction assembly of steam turbine. Building a turbine needs careful work and alignment of each part. So these are base, casing, rotor, and control parts must all fit perfectly. So after setting up, the turbines is tested to make sure it runs smoothly and safely. So first step, foundation preparation. A strong concrete base is built to hold the heavy turbine and stop it from shaking too much. Bolts are placed to keep it steady. Base plate installation. The base plate is placed on the foundation and labeled to make sure everything will fit correctly later. Casing assembly. The bottom part of the casing is set first and aligned, and the top part is placed and bolted. Gasket or seals are added to the top stem from leaking. Rotor and shaft installation. The rotor and the shaft are carefully placed inside the casing, aligned with the bearings so they can spin smoothly. Tested to make sure there's no vibration. Blade and nozzle arrangement. Blades are attached to the rotor nozzle and fixed in place. Both are arranged to make them flow correctly and move the rotor efficiently. Bearings and sail installation. Bearings are installed to help the rotor spin easily. Sails are added around the shaft to keep steam from escaping. So piping and auxiliary connection. Pipes for steam, oil, and cooling are connected. Everything is checked for leaks and covered with insulation to keep the heat inside. Control system and safety devices. The control parts like bulbs, sensor, and emergency stops are set up. They help control the turbine's speed, pressure, and safety. So final alignment and testing. All parts are checked and aligned properly. The turbine is tested to make sure it runs smoothly and safely before full operation. Safety devices. Number 1, overspeed governor. What is overspeed governor? Prevent the turbine from spinning to the fast by automatically reducing the steam supply when the speed exceeds the safe limits. Number 2, emergency stop valve or trip valve. What is emergency stop valve or trip valve? Instantly shut off the steam flow during emergencies such as overspeed, low oil pressure, or high vibration. Number 3, pressure relief valve. So what is pressure relief valve? Open automatically when steam pressure becomes too high, or releasing extra pressure to prevent explosion or damage. So number 4, temperature and sensor alarms. So what is temperature and sensors and alarms? So detect high temperature in parts like bearings and casing. trigger alarms or automatic shutdown if overheating occurs. Number 5, lubrication oils system. So what is lubrication oil systems? So monitor oil pressure and temperature. If the oil fails, it automatically stops the turbine to protect the bearing and the shaft. So number 6, vibration monitor system. So what is the vibration monitoring system? Check for excessive vibration that may indicate imbalance or damage, so sends warning or stops the turbine if needed. So safety devices protect the turbine from danger. They stop it from running too fast or under too much pressure. This part help avoid accident and damage. So these are the automatic control system. The automatic control system is the turbine brain that automatically controls speed, pressure, temperature, and load. It keeps the turbine running safely and efficiently by adjusting the steam flow and shutting down the system during unsafe condition. So number 1, speed governor system. So speed governor system automatically controls the amount of steam entering the turbine to maintain constant and safe speed. Number 2, automatic pressure control. Keeps the steam pressure stable for efficient operation. Number 3, temperature control system monitors and regulates the temperature of steam and turbine parts to prevent overheating. So number 4, automatic shutdown system or trip system. Detect dangerous condition like overspeed or low oil pressure and immediately stops the turbine. Number 5, load control system. Adjust turbine output automatically depending on how much power or load is needed. Number 6, vibration and condition monitoring system. So vibration and conditioning monitoring system continuously check for unusual vibration or movement and alerts operators or shut down the turbine if necessary. So they are the operation control mechanism. So the operation control mechanism manage how the steam turbines runs and ensure it works safely, smoothly, and efficiently. It includes system that control the speeds, steam flow, pressure, and load of the turbine. So number 1, steam admission control. This steam controls how much steam enters the turbine using valves. When the more power is needed, the valve opens wider to let in more steam. When less power is needed, it closes slightly. So number 2, speed control governor system. The governor keeps turbines speed steady even if the load changes. It automatically adjusts the steam flow to prevent the turbine from running too fast or too slow. Load control. This adjusts the turbine's power output that depending on the demand. It ensures the turbine produce the right amount of electricity required by generator or grid. So pressure and temperature control. So this system maintain the right steam pressure and temperature for efficient performance. If pressure or temperature gets too high, control valves or safety system act to prevent damage. So automatic shutdown or trip systems. So this is a protection system that automatically shut down the turbine if dangerous conditions occur, such as overspeed, high vibration, or low oil pressure. Monitoring and feedback system. Sensors constantly check important data like speed, pressure, temperature, and vibration. So the control panel or computer uses this data to make adjustment and maintain safe operation. To summarize the components of steam turbine. A steam turbine is a machine that converts the energy of high pressure steam into mechanical energy, which is then used to generate electricity. It is made up from important components such as casing, rotor, blades, nozzles, bearings, sails, shaft, and control system. Each designed using strong materials with withstand heat, pressure, and rotation. So, the construction assembly of a steam turbine require precise alignment and strong connection to ensure efficient performance and prevent leak or vibration. To keep the turbine safe, several safety devices like governors, relief valves, and trip system are installed to protect it from damage caused by high pressure, temperature, or overspeed. The automatic control operation mechanism manage the turbine speed, load, and steam flow to maintain stability, safety, and efficiency. So this system work together to make sure the turbine runs smoothly and safely and continuously and product power. So okay guys, that's all for today, and I hope you learned something about steam turbine components, and thank you for your listening. Alright.